Okay, cool. So we're doing quicksort. I'm gonna restart all this. Yes. Let's this is the program we're running. I'm gonna run just so it shows that it's actually running um the sorting. There's one. An empty list will always be, well, it's empty, and a single element um list is always sorted, right? So last time I went over time, I'm recording this again real quick. So yes. Okay, let's get started. So, quick sort for integer lists. Again, we have two cases, the empty list case and the single element list case, right? Once it hits either of them, it just returns the same thing, right? And then this is the um recursive cases, right? So the first case is the pivot and the rest, right? So once it finds the pattern, it finds the pivot, which is the first element as suggested, and then the rest, right? The first element becomes the pivot, and then, for example, on the input we had, the first element would be 5, and it becomes the pivot, right? It is used to divide the list into smaller and larger values. Inside the block right here, these are the comments. We have a partition, we have a let, and then fun partition, and then we have a base case where we have a base case that if there's no elements left to examine in the list, again, it picks the first element, recursively goes in, and then it picks the first element again in the smaller list. Once you hit the when there's like a pivot and nothing else to examine, then you're done, right? Bam, then that's your way to stop the recursive case. Otherwise, you have the pivot and uh, a .cs, C's, sorry. A here represents the current element being examined. C's is the rest of them, and we have still our pivot, right? Then again, we have X and Y. We have two values, X and Y, and then partition, again, partition is be the pivot, and then the rest um of the list, right? I think again, A is being the element being examined. A is compared to the pivot. In this case, for example, we had 5, and the first element would be 2. So 2 is compared to 5. 2 is less than 5. Again, if A is less than the pivot, then it gets added to list X. And then Y is for the bigger ones, right? So again, this 2 would be on the smaller, bigger, smaller, bigger, right? And then element, yep. And the process continues until every single element has been examined, and we obtain two lists. Notice the recursiveness of it. Notice that we also, again, once we hit our step, we have two lists. We would have a smaller and a bigger list. Again, calling on partition. Once we have the smaller and bigger lists, we use that to recursively move through it again, right? So the recursiveness of it is you get the list, you restart the whole process again with the smaller list, going through it all over again. Once you have smaller partition, the smaller partition is sorted, and then the bigger one is used for concatenation, right? For example, when pivot is 5, the partition produces 2, 1, 8, 7. And then the recursive calls break that into 1, 2, 7, 8. And then the result becomes 1, 2 in the smaller, the pivot in the middle, and then 7, 8 at the end. And then again, this just gets put together as 5 in the middle, 1, 2, and 7, 8. And I'm gonna stop recording because I'm past 5 minutes. Thank you.